All right, so in this video, we're going to be covering quadratic functions, and we're going to be focusing on their graphs. So the first thing we want to go over is what does a quadratic function look like when we graph it? So when we graph it, it looks like either one of these two. So kind of like a happy face, right, or a sad face, but we call these parabolas. So these two are the different types of parabolas we're going to be seeing in this section. When we graph a parabola, there's a point that's very important. We call that point the vertex. The vertex is the turning point of a parabola. So for example, here we have a parabola. This would be the turning point, meaning this is the vertex. Now, when you have a parabola that opens down, in this case, the vertex, we could call it a maximum point because it occurs at the highest point. Now, when we have a parabola that opens up, like this one, the vertex actually occurs right here. But now in this case, the vertex is a minimum. Okay, so the vertex could be either a maximum or a minimum depending on how the parabola opens up or down. Now, there's going to be two types of quadratic functions we're going to be dealing with today. The first one is what we call standard form, and the other one is what we call vertex form. But let's go ahead and focus on this one first. When you have something in standard form, it means it looks like this. You make sure you make a note of this. In standard form, you don't have parentheses. So if you notice, there's no parentheses here. So if you don't have parentheses, you could right away know that the equation is in standard form. Now, in order to graph an equation that's in standard form, we're going to follow some steps. So the first step we're going to follow is determine if it opens up or down. Because remember, a parabola could look like this, or it could look like that. So in order to determine which one of those two we're going to have, we're going to look at a. And a is the number in front of the x squared. Okay? If a is negative, that means that the parabola is going to open down. So again, negative is kind of like a sad face, right? So it's going to open down. Now, if A is positive, then that is kind of like a happy face, right? So a positive face. That means that the parabola is going to open up. Okay, so that's always going to be step number one. Step number one, determine if it opens up or down, and it all depends on this number. If it's positive, open up. If it's negative, it opens down. Now, once we have this determined, we go to step two. Step two, we're actually going to have to figure out exactly where is the vertex. And again, vertex is that little point, the turning point of the parabola. So don't let this scare you, but just make sure you have it written down, right? To find the vertex, we're going to have to use this formula. Okay, so the first thing we're going to do is we're going to have to find the x coordinate, and we're going to use this formula. It's going to be negative b over 2a. So again, this is your b value, and this is your a value. So we're just going to substitute them here, and that's going to give us the x coordinate. Now, once you have the x coordinate, you're going to substitute this, whatever answer you get, back into the formula, and then whatever you get is going to be your y coordinate. Okay, so again, if you didn't understand that, don't worry. We're going to be doing an example in a little bit, but that's step two. You find the vertex. Now, something else that goes along with the vertex is what we call our axis of symmetry, or your line of symmetry. So once you determine your x coordinate here, your line of symmetry is always going to be the same. Okay, so your line of symmetry is always going to be x equals negative b over 2a. And again, we're just jotting out notes right now. When we do an example, you'll see how we use this formula. Now, step three. Up to here, we already know the parabola opens up or down. We already know the vertex. Now we have to find the x-intercepts. So to find the x-intercepts of this, we're going to have to set this equal to 0. So you're going to copy paste it, set it equal to 0, and you're going to solve. Of course, in order to solve this, we're going to have to factor out, which we already know how to do to this point. And again, if something is not factorable, then you cannot factor it out, then you may need to use a quadratic formula. There's some of you who just don't like factoring, so you could go straight to the quadratic formula, and the quadratic formula is right away going to give you the x-intercepts. So again, x-intercepts can be used by either factoring or using the quadratic formula. It's up to you, whichever method you want to use. Now, step four, we have to find the y-intercept. This is super easy. To find the y-intercept, all you have to do is compute f of 0, which is the same thing as substituting all the x's with 0 and simplifying. So I think this is pretty easy. So to find the y-intercept, you're going to put a 0 here and a 0 there, and then you're just going to compute that. Whatever you get, that's your y-intercept. And then finally, step 5, you're going to plot all the information that we got from steps 1 through 4, and then we're just going to connect. So that's how we will be graphing these problems. All right, so let's go ahead and try a problem here. Again, like I said, you're going to plot all the information, and then if you need additional points, you could find some as well. But let's go ahead and try this one out. So this is a problem. Again, if you open up your homework and you see a problem like this, first thing you should notice is, hey, there's no parentheses, so this is in standard form. So we're going to use the 5 steps we just talked about. So first thing we're going to do is determine if this opens up or down. So again, in order to determine if something opens up and down, we look at the number in front of the x squared. So in this case, since a, which is the number in front of the x squared, is negative, the parabola is going to open downward. And again, downward means like this. Okay, so look at that. We didn't need a calculator. Just by looking at the a value, since it's negative, it means it's going to open down. So we already have something here. Now, in order to find the vertex, we have to pull out the formula, right? The formula is negative b over 2a. So every time you want to know the vertex, you use that formula. Remember, this right here is your a, this right here is your b, and this right here is your c. So negative b is going to be negative 16 over 2 times a, and a is negative 2. So that's how I got up to this point. Now from here, I just multiply. 2 times negative 2 gives me the negative 4. And then from there, simply I just divide. So negative 16 divided by negative 4 gives me a 4. Now, if you remember, vertex is always 2 points. We need an x and we need a y. The answer that you get right here from the negative b over 2a, this is your x value. So I'm going to come over here, and I already know the x value of my vertex. I am still missing the y. So what you do now is that whatever x value you got, all you have to do is just come back and substitute it into the formula. So I'm going to have negative 2 times, instead of x, I'm going to put a 4. So negative 2 4 squared. Plus 16, instead of the x, I'm also going to put a 4. So 16 times 4 minus 30. Okay, so that's all you have to do. Use the formula to get the first value. Input that value back into the formula, and that's how you're going to get your y value. Okay, so I'm going to come over here, and now I know that this is a 2. Okay, so again, this is the way you would do it. I didn't do it step by step, but you can calculate this on your own, right? So just remember, you have to do parentheses and exponents first. So 4 squared gives me 16. Negative 2 times 16 gives me negative 32. And then I do 16 times 4, which should give you 64. And then you have minus 30. So that is how I got the 2. Okay, so if you were wondering, like, how in the world did you get a 2? You have to do order of operations here, and then you end up with this, and then you could just put that straight in your calculator. So negative 32 plus 64 minus 30, that's how I got the 2. All right, so look at this. This is my vertex, 4, 2. Again, vertex always have to be in ordered pairs. If you don't put the parentheses, you are going to get it wrong. So the vertex is that. Now, the line of symmetry is always, make a note of this, it's always going to be x equals whatever you had on your x coordinate. Okay, so it's going to be x equals and 4. If you want to know the reason why, let me just go ahead and show you real quick. We know that my vertex is 4, 2. So let me just give me a minute here. So we're going to have 1, 2, 3, 4. 1, 2. So this is my vertex. We know that the graph is going to open downward. So this is not super accurate, right? But it's going to look something like this. The line of symmetry is just the name of the line that cuts the parabola exactly in half. So all you're going to do is you're going to make a line through the vertex, and that's the line of symmetry. It means that it cuts the parabola exactly in half. So again, if you were to fold a parabola through that line, it would be super symmetrical. So if you notice, it always goes through this point on the vertex. So that's why we always use the 4. Or in your case, the x value. Okay, so it's pretty simple. Just remember, you always have, since it's a line, you always have to put x equals because it's an equation. Okay, all right, we have step 1, step 2. Let's go ahead and do step 3. So if you go back to your notes, in order to find the x-intercepts, I have to set this equal to 0, and we're going to have to solve. So don't freak out, right? But what we're going to do is that we're going to have to set this equal to 0. But in order to solve this, I do have to factor it out. And again, we're experts on factoring by now. So the first thing, remember, you always factor out is your greatest common factor, which is a negative 2. If I factor out a negative 2, I'm left with x squared minus 8, right? Because that's what gives me positive 16. And then a 15, because 15 times negative 2 gives me the negative 30. Now from here, this is a trinomial. You should know by now that in order to factor a trinomial, we could use the AC method. So two numbers that multiply to 1 times 15, which is 15, and they add to -8. So those two numbers are -5 and -3. If you need help with that, go back to the video that we covered on factoring, because by now you should already know how to do that there. Now from here, like the notes say from a couple of slides back, we're going to set this equal to 0. And hopefully you also remember that when you set something to equal to 0, you grab this one, you set it equal to 0, and you also grab that one and set it equal to 0. Now, if I set this first one equal to 0, I have to move the 5 to the other side, so it becomes a +5, giving me my first x-intercept. And then if I set this one equal to 0, I have to move the 3 to the other side, and it gives me a +3. And that's how I get my second x-intercept. Okay. If you're wondering why I put a 0 here, remember x-intercepts are supposed to be points, meaning they have to be an ordered pair. It's always going to be the answer you have, comma 0. And then same thing here, right? The second answer I have, comma 0. So that's how I find my x-intercepts. Now for step 4, to find the y-intercept, again, go back to your notes we did in a couple slides back. All you have to do is just substitute a 0 into all the x's and then simplify or compute. So if I put a 0 in all the x's, remember, look at this. I just copied this down. Instead of the x's, I put 0. 0 squared is 0 times -2. That's just 0. 16 times 0 is just 0. So I'm left with 0 plus 0 minus 30, which gives me -30. And again, y-intercepts, just like the x-intercepts, are supposed to be points. In this one, when you're talking about a y-intercept, your answer goes on the y-coordinate, and on the x-coordinate, you put a 0. All right, so look at the difference. For x-intercepts, we had to factor. Our answers go on the x values, and we put zeros on the y values. Now for the y-intercept, whatever answer we get goes on the y value, and we put zeros on the x. All right, so we're done with steps 1 through 4. So for step 5, all we have to do is just plot everything we know. So if you look back on your notes, we found out that the vertex was 4, 2, which is right here. We also found 2 x-intercepts, one of them at 3, which is right here, and we had another one at 5. And then, of course, we just connect. And this all makes sense because from step 1, we learned that the graph was supposed to open down, which it does. Okay, if for some reason you would have done this problem and your 3 points would have been like this, you would have to connect them like that, and you know this would have been wrong. Because again, this negative says the graph was supposed to open down. So then you will have to go back and double check your work. But on this one, it turned out very nicely to open down. All right, let's go ahead and try another example. This one, they're not asking us to do all the steps. They just want us to find the vertex and determine if it's a maximum or a minimum. Okay, so we should already know how to do that. So the first thing we notice is that since a, remember, a is the number in front of the x word. Since a is negative, that means that the parabola is going to open down. Because remember, negative is like a sad face, right? So negative is going to open down. So that means that my vertex, how do you call the vertex when it's up here? It means that it's going to be a maximum. So we have already answered half of the question, right? They ask us, find the vertex, determines a maximum or minimum. Obviously, it's going to be a maximum because it opens down. Now, in order to find the vertex, remember, this is in standard form. How do I know? There's no parentheses. So this is in standard form. I go back to my notes, and the notes say, hey, when you want to find the vertex, you have to use the formula -b over 2a. Just so you know, on your notes, the negative is up here. That's okay. I put it up here because I think it might be easier. So I would just go with this, but it's the same thing. So b is 32, so it's going to be -32 over 2 times a, which is -4. I simply multiply 2 times -4, which is -8, and then I just divide. -32 divided by -8 is 4. Now, if you remember, this number is the first value of my vertex. So right now we have the 4. I still need the y. If you took good notes on the last problem, you should remember, okay, in order to find the y, I just have to substitute the answer I just got back into the equation. So let me go ahead and erase this real quick. And now what we're going to do is that I'm going to use the equation. So -4x squared plus 32x minus 20. Of course, instead of the x, now I'm going to substitute a 4. So I'm going to have -4 times 4 squared plus 32 times 4 minus 20. If you're going to do this manually, then you must know that you have to do this first. So 4 squared gives me 16. This one doesn't have an exponent, so I can multiply 32 times 4, which is 128. And then the minus 20, I just bring it down. And then from here, you could just put this straight in your calculator, and I get 44. Okay, so by now you should know this is going to be your x value and this is your y value. So that means that my vertex is 4, 44, and the function has a maximum of 44 at x equals 4. Okay, I might have lost you there, right? So just make sure you write that down. So the vertex is 4, 44 because that's what I got. But now, if you want to phrase this into a sentence, this is what you would say. The function has a maximum of, here you put your y value, which was 44, at x equals 4. So this is obviously your x value. Okay? So again, the maximum always occurs, or the minimum always occurs at the y value. And then you say that at x equals, and then you just give me your x value. All right? So again, hopefully that made sense there. Now let's go ahead and try one more example. On this one, they're asking us for the x-intercept, so no need to worry about the vertex. I really don't care if the function opens up or down. We just have to find the x-intercepts. So I just threw this one in here just so we could practice, because in order to find the x-intercepts, I'm going to have to factor this out. So I set this equal to 0, and then of course I have to factor this out. We always start by factoring the greatest common factor, which in this case we don't have one. So I just go straight to finding two numbers that multiply to 1 times -7 and they add to -6. So those two numbers are -7 and 1. And then from here, we set each one of those equal to 0. So I bring this one down, set it equal to 0. I also bring this one down, set it equal to 0. In order to solve the first one, I move the 7 to the other side, so it becomes +7. And on this one, I move the 1 to the other side, so it becomes -1. So those are my two answers. But again, remember, x-intercepts are always written down as ordered pairs. So here we go. 7, 0 is my first x-intercept, and my second intercept is -1, 0. All right. Okay, so I think that was enough for standard form. Like I mentioned earlier, sometimes your equations are going to pop up in vertex form. Okay, so again, when you open up your homework or your test or wherever you are, right, whenever a problem comes to you, the first thing you have to do is determine if it's in vertex form or standard form. So like I mentioned earlier, standard form do not have parentheses. Now, if your problem has a parentheses, then that gives it away. This is in vertex form. So we're going to follow the same 5 steps, but I'm going to show you because they might change a little bit. So step number 1, we're going to determine if it opens up or down. Again, what gives it away is A, but now A is the number in front of the parentheses. And just like we talked about this earlier, right? If A is negative, the parabola is going to open down. And if A is positive, the parabola is going to open up. So this didn't change much, right? But now the A is no longer in front of the X word, it's in front of the parentheses. Now, step 2. This is really fun because here you don't need a formula. For standard form, we had to use -b over 2a, but for vertex form, it's called vertex form because the vertex is right there. What you're going to do is you're going to look for 2 letters. Your x value is going to be the opposite of whatever is inside the parentheses. So if I have a -h, the vertex is going to have a positive h. And then your y value is going to be k, and k comes from whatever is outside the parentheses. Not in the front, but over here added to. If this one is a negative, a subtraction, then your y value is going to be negative. Okay, so make a note of it. Your h and your k are going to come from here, your h from inside and your k from the outside. The only one that's going to change sign is the h. So make sure you make a note of that, right? So you grab the opposite of whatever is in there. Okay, and just like we learned in the previous form, your line of symmetry is always x equals whatever is the x value here. Okay, so in this case, it would be h. All right. Now, for step 3, we're going to find the x-intercepts, right? And in order to get the x-intercepts, it's just like on the previous one. We're going to set this equal to 0, right? Just like I have it here, right? And you're going to solve. And again, don't worry. We're going to do an example in just a little bit. Step 4, we're going to find the y-intercept. And again, it's the same procedure. In order to find the y-intercept, you're going to substitute all your x's. So I'm going to put a big fat 0 here and then just calculate. And that's going to give you your y-intercept. And then step 5, again, it's the same thing. So I'm just going to ignore this, but you plot all the information you have from steps 1 through 4, and then you just connect and you're done. So let's go ahead and do an example here. So first thing you notice, right, is this problem has parentheses. So that's a dead giveaway. This is in vertex form. Now, first thing they ask us, or the first step in order to graph this, is we have to determine if this opens up or down. And we already know, we just look at A. This right here is our A value. And we just care if it's positive or negative. So since my A value, which is 5, is positive, that means that the parabola is going to open upwards. So it's going to look like that. Now, second thing we want to do is find the vertex. Again, for this one, you don't need a formula. The vertex, if you go back, you look at your H value, which is whatever is in here, and then you look at your K value, which is that. So actually, right there is our vertex. But remember what I said, the H value, you do the opposite. So my vertex is going to be, instead of positive 2, it's going to be negative 2, comma, whatever number is right here. So negative 5. Okay, hopefully you were able to understand that. So remember the vertex, because this is in vertex form, it comes straight from the function. So you grab the opposite of whatever is here, comma, whatever number is here. And now the line of symmetry is always x equals whatever value you have right here. So x equals negative 2. All right, step number 3, we have to find the x-intercepts. So in order to find the x-intercepts, we're going to set this equal to 0. Right, so if you notice, I have it right here. We set it equal to 0. And then here, you don't have to factor out or anything because all we have to do is just move things around. So in order to solve this, the first thing I have to do is move this negative 5 to the other side, which makes it a positive 5. So that's how I got up to this point. Now, I have to leave the x by itself, so I have to get rid of this 5. How do I get rid of the 5? Since they're multiplying, I do the opposite. So I'm going to divide both sides by 5. If I divide this side by 5, the 5's cancel out. And then if I divide this side by 5, 5 divided by 5 gives me a 1. Okay, I kind of ate my 1, so just pretend it's right there. Okay, so that's how I get to this point. The 5's cancel out, leaving me with x plus 2 squared, and then 5 divided by 5 gives me 1. Now, in order to get rid of a square, hopefully you remember, we square root both sides. So I square root this side, I square root the 1. The square and the square root cancel out, leaving me only with x plus 2. And hopefully you remember, but if you don't, make sure you make a little note. When we square root, we always have the plus and minus. So the square root of 1 is just 1, but we have a plus and minus 1, meaning, hey, we're going to have 2 answers at the end of the day. All right, after this, I move the 2 to the other side, so it becomes a minus 2. So let me just erase all my stuff here. So hopefully you were able to follow me through to this point, right? We have x equals plus and minus 1 minus 2. Now, before you get all excited and be like, oh, I could combine like terms, I could do 1 minus 2. Remember, we are going to have 2 answers. One of them is going to be found by using the positive 1, and the other one's going to be found by using the negative 1. So let's go ahead and start with the positive. If this is a positive 1, 1 minus 2 gives me negative 1. Okay, and that's how I find my first x-intercept. Now I come over here and I pretend this is a negative 1. Negative 1 minus 2 gives me negative 3. And that's how I find the second x-intercept. And again, remember, x-intercepts always have to be written down as ordered pairs, just like that in parentheses. And there's always going to be a 0 on the y value. So the 2 answers that you got take place of the x values, and then the y coordinates or the y values are always 0. All right, step 4, we're almost done. Step 4, to find the y-intercept, remember it's always the same thing. You just substitute a 0 on the x value. So if you notice, I brought it down just the way it is, but I put a 0 on the x, and then we just do the order of operation. So 0 plus 2 gives me 2. Now, order of operation, say I have to do exponents first. So 2 to the second power gives me 4. And now I can multiply the 5 times the 4, which gives me 20. And then the minus 5 is still there. So 20 minus 5 gives me 15. And that is my y-intercept. Of course, y-intercepts always as ordered pairs with a 0 on the x value. All right, since we have already found all of our information, all we have to do now is just graph. So look at that. We found that the vertex was negative 2 comma negative 5, which was right here. And then we found 2 x-intercepts. We found one at negative 1 and we found one at negative 3. So I plot those points, then I connect them, And then I double checked that this makes sense. So according to step 1, this parabola was supposed to open up, which it does. So we did a good job. So there we go. That's how you graph an equation in vertex form. Now let's try a couple more examples, right? So this one, we don't have to do all of the steps. They're just asking us to find the vertex. Super simple. But there's something weird with this function, right? In order to find the vertex, I look at the number inside and I look at the number outside, but there's no number. So if there's no number, remember it's an invisible plus 0, right? So just so you know, and I wanted to put that one in here for a reason. If there's no number outside, it's just an invisible plus 0. So now we know we have our two values. We have our h here and our k here. So in order to find the vertex, remember I grab the opposite of this. That's going to be my x value. And I grab this right here, which is going to be my y value. So I totally skipped the first part, but let's go to this one. So again, that's how I find my vertex. So let me go ahead and erase this. So the vertex is going to be -1, 0. Again, because there's nothing over here, so that's your y value. And then how do we know if this is a maximum or a minimum? Well, we look at A. So A is an invisible -1. And since it's negative, it means that the graph is going to open down. So that means that the vertex is going to be a maximum. All right. So that's what we do. That's how you find the vertex, and that's how you determine if it's a maximum or a minimum. Now, just like we did on the previous slide, I want to make sure that you know how to word this properly. So the vertex was -1, 0. Another way to say this is we say the function has a maximum of 0. Remember, it's always your y value at x equals -1. All right, so that's how you would figure this one out. Okay, so next thing I want to talk about, and this is going to be really short, for when we talk about quadratic functions, they can also ask us about the domain and range. So this is how you're going to find the domain and range. When we're talking about quadratic functions or parabolas, the domain is always going to be all real numbers, or in interval notation, -infinity to +infinity. So always and forever, that's always going to be the domain. Why? Because parabolas always stretch from left to right all the time, right? So they keep getting wider and wider. Now, the only thing that's going to change is the range. The range is going to be restricted by the vertex. So depending where your vertex is going to depend what is going to be your range. So I know this makes no sense, so let's go ahead and do a couple examples. So here we have this function. Again, we graphed this one earlier. So this is a problem we just did. Look at the graph. What is going to be the domain? That's a trick question, right? Domain, like I said in the previous slide, is always going to be -infinity to +infinity. Now, the range, like I said, depends on your vertex. So this right here, the y value is -5, and that's what I look at. I don't care about the x. I care about the y value. Now, from here, does the graph go up or does the graph go down? The graph goes up. So the lowest point is -5, and the highest point, since it goes up forever, is going to be infinity. So that is my range. And like we have discussed plenty of times before, infinities always go with parentheses. And since there is no open circle, we assume that it's closed, meaning that we have a bracket. Okay, now a word of warning. If for some reason this would have been a new problem and you don't want to, and you didn't have the graph, so let's pretend we didn't have the graph. You don't have to go through steps 1 through 5 in order to graph. You could just find the vertex. Remember, the vertex is the opposite of this, -2, comma, and then your y values right here. So knowing that this is a vertex, you would just make a little point here, -2, -5. And then you would have looked at A. Since A is positive, you know that the graph would open up. And that's pretty much all the information that we would have needed in order to find the range. Right? So you know that it's -5 and then the graph goes up. So that's all you need. Okay, let's try one more. Again, this is from a previous problem. Okay, that was meant to be a straight line, I'm sorry. So this is from a previous problem. We already have the graph here. We know that the vertex is right here, right? What's the vertex here? 4, +2. So domain, trick question again, right? Domain is always -infinity to +infinity. And then the range, again, range is restricted by the vertex. So the y value here is 2. Now, so there's going to be a 2 somewhere in the range. does this graph or this parabola open up or down? It opens down. So we always start, when we're talking about range, we always start with the lowest point first. What's the lowest point? The lowest point is somewhere down here. So the lowest point is negative infinity because it keeps going all the way down, comma, the highest point obviously is the 2 from the vertex. Infinities always go with parentheses, and the 2 would go with a bracket, again, because it's a closed circle. We don't see it, but it's not open, so we assume that it's closed. All right. Now, the last thing we're going to talk about really quickly is increasing and decreasing, right? So we've already talked about this before, but I just wanted to make sure we threw it out here as a refresher. When we have a parabola, it's always half and half. Half of the parabola is increasing, the other half is decreasing. So this is how you determine, right? So the parabola opens up like this one. The first half is decreasing. And when we're talking about increasing and decreasing, we look at the x value. So let me go ahead and just go back. So this is my vertex. We're going to be using the -4. Now, there's two parts. There's negative infinity to -4, and there's the other part, -4 to infinity. So those are going to be my two answers. Now, the first part of the graph is decreasing. So it's decreasing from negative infinity to -4, right? That's the first half of the parabola. Now, obviously, the other half is increasing, and that's from -4 to infinity. Okay, and in case you hadn't made a note of this earlier, just remember, for increasing and decreasing, you always use parentheses everywhere. There's never going to be a bracket. So we only use brackets when we're talking about domain and range. But here, always and forever, parentheses. All right, we're going to do 2 more problems, and then we're just going to wrap this up. So here is the same function we've been talking about before. Again, remember, for increasing, decreasing, I only care about the x value. So I have two answers. I have negative infinity to -2 and -2 to positive infinity. Now, which one's which? Well, let's figure out. So in this part, from negative infinity to -2, what is the graph doing? The graph is decreasing. So my answer for decreasing is negative infinity to -2. Now, from -2 to infinity, in this part of the graph, what's happening? The graph is increasing. So that's why that's my answer for increasing. All right, the last example for this video is the other parabola that we also graphed earlier. Again, I just chop this into 2 pieces. The first piece, the parabola is increasing, and this piece is from negative infinity to 4. So that's my first answer. And now in the second part of the parabola is decreasing. So what chunk is that? Well, the next chunk is from 4 to infinity. And just like I said, we always use parentheses for this.